Students, see, yesterday we conducted the experiment. No, we just conducted the experiment on friction. Okay, so we had used this. This was tied to a string and it was let down, and we were adding water to that so that we were loading it. And this was the container. So this container was on the carom board, and we had to find the coefficient of friction between this surface and the carom board surface. Okay, and what you have is a small weighing machine. Okay, so I'm going to turn it on, right, and you're going to do the measurement of this. Okay, so I am placing the container on this, and see what is the reading here. Please get up and see.
26.90.
Louder.
26.90.
Okay, fine. You note it down. So you should note it down as M suffix C, that is container, is 26.90.
Yes.
Okay. Now we are going to weigh the trolley which was there on the carom board, and we are going to find the coefficient of friction between this surface and the carom board. So I'm going to place it here gently. It is very, very soft.
Place it near.
No, you get up and see that first. See that here.
82.82.
82.82. Please write it down. 82. The setup that we had was something like this. That we had a container, right? So it has water. So the mass of this, we took it as mc. And then we had a string, and then there was a pulley, and the string was on our container, on a trolley, not the container, trolley. And this is the carom. Okay?
Yes, sir.
And this trolley contains some mass, so this is the mass of the trolley. And what we just now measured was the weight of the container, mass of the container is how much?
26.90.
26.90 grams. And this of the trolley?
82.82 grams.
82.82 grams. Okay, so this is what we have taken down. And then we went on putting water in this, and just at that point the trolley started moving. So you know that there was tension in the spring and the friction is acting in this direction. The frictional force is acting in this direction. I think all of you know this. Okay? So as long as this trolley was at rest, so what are the Newton's law here? That the gravitational force on this was mc into g, and the tension was up, and here the same tension will be here, and friction force. So when the system was at rest, what are the conditions? Again, here mt into g is acting down, the normal force is acting down. So all these forces, so on this trolley, if you see here, there are four forces acting. One is the frictional force, one is the tension force, and one is the normal
force,
and one is
gravitational force.
Excellent students, keep answering. So this is it, and all of them are, see, so this is equal to this, and this is equal to this, and therefore all of them were at rest. And here you see, this force is equal to this force. Therefore, this is also at rest. So, in accordance with Newton's law, the condition for rest is satisfied. Okay. Now we went on putting water in this. At a particular instant of time, when the mass of this was so much, the trolley just started moving, and it moved from this position to this position. The trolley moved from this position to this position. Right? Okay. Now, what was this length? And how much time did it take to go from here to here? That the camera has recorded. right? So we will play the video and we will measure the length and the time duration. Okay, done? Yes. Fine. So I'll play the video here. So I'm going to play you the video that we captured yesterday. We all conducted the experiment, and from this we are going to do the measurement of distance traveled and time taken. Okay. Now you will see how we are going to use all this data and find out the coefficient of static friction and coefficient of kinetic
friction.
Yes. So here we go. Okay, now what we see for setup here is that there is a container here which is got weight. So it's got the weight of the container is empty and its weight is empty, and there is a stream which is connected to this and it carries fully here. And then I have a container here, right, in which I can put water and increase its mass. Okay, and this is 3D surface. This tension is balanced by the friction, and therefore this trolley is also in a state of rest. So what I'm going to do now is I have got ink pillar with water in this. So I will add small drops of water until it just starts flowing, and we are increasing the mass of that by putting water. Keep it. Thank you. Now, follow. Okay, so you saw the trolley just started moving and it accelerated. Okay, now, so you can see here, right? So you take down the readings now here, because this is what is the idea behind what we are doing. So that we conduct the experiment, we capture it. Just now it moved. So what is it? This is 29. Correct? This is 30. 29. Yeah, you're right. 29 is the position. Right? And what is the corresponding time there? 1.4. Sorry, don't take 1. 42.735. 42.735. Okay? This is the instant of time at which the trolley was in this position. Okay? Now we will take the reading. See, the trolley is moving and then it moved here. So now we will take the reading. See, we are now going to take the initial position, final position, and we will take the acceleration between this as average acceleration. Right? Okay. So what is the position 9. Here? 5. What is the position? This is 10, 9.5. Okay, 9.5. Okay, right. This is 9.5, and what is the time? 43.824. 43.824. Okay. Okay. So now we have noted down the first position, right? That is the L1. What is the L1 equal to?
29.
29. Position 29. Okay. And what is the L2?
9.5 centimeter.
9.5. Hey, L2. That other position.
Yes, sir. 9.5.
9.5. Okay. Right. These are both in inches. We are using an inch scale. So now we will calculate the length that it has moved. Or simply, I will take it as L, the length that it has moved. So 29 minus 9.5. That will give you how much?
19.5.
19.5. So it has moved 19.5 inches. Right? Now, what was the final time?
Final time 43.8.
Louder.
43.824.
824 seconds. And what was the initial time when it started the journey?
42.735.
42.735. So if you subtract this from this, you get the time of travel. Okay. So 4 minus 5 is 9, 11 minus 3 is 8, and 0, and here, what do you get here? 1. So it has traveled for 1.089 seconds. Okay? Now, so it has traveled this distance and in this time. What is the acceleration? So for that you know the formula. X is equal to half a
square.
Now here our x corresponds to this and time corresponds to t. Therefore the acceleration, this acceleration is the average acceleration during this period will be 19.5. Okay, wait, we will convert this into SI system. We will first convert this into SI system. So how will you convert this into SI system? 19.5 into 2.54. Okay, divided by 100. So I have a calculator here. I'll quickly do it because we need to save time. So 19.5 into 2.54 divided by 100. So that gives you 0.495. Right? 0.495 what? Meters. So we can use that meters here and do the calculation. Okay? So acceleration A will be equal to x is 19.5. I will not take it as 19.5 because now just now we got it as 495 into 2 divided by t square. What is t square we got here? 1.089 square. So we get the acceleration of this. Okay, when we do this calculation. Anyways, I have the calculator here. I am doing it. So please tell me
0.495
into
2 divided by
1.089
whole square.
1.089 whole square. So we are going to get here acceleration is 0.8347 okay, meters per second square. So we have just now found out the acceleration of the system. Okay, understood? Right? So this is one of the calculations that we wanted, and we just have got the calculation. Okay. So having got this calculation here, this data, so now we will we will get into the other details. So the other details are like this. This data is important for us. Right. So now our previous one we had shown you this trolley and all. Okay? Right? I hope all of you remember this. So this is called as the schematic diagram, right? So whatever experiment we did, we conducted, this is the schematic diagram of that experiment. Okay? Right. So now I will start writing the equations. When the trolley just started moving. Just started moving means you can say it is at rest also and it is moving also. So whichever one you can take. That's called just started moving. So here I write the equation for this. What is the equation for this? Here you see the tension. See this is also at rest. So the tension T will be equal to
MC
into G. Right? And here also the tension is equal to what?
Friction.
Yes. The static friction force. So this is coefficient of static friction. This is what? Mass of the trolley into G. Right? Mass of the trolley into G into mu s. Mu s is the coefficient of static friction. So here you can see, you can knock off this 2. So you can knock this, right? And then you will get here US will be equal to MC by
MT.
Okay, so those values we'll have to just put it, and we will get US. Okay, so let me do that. So what are those values? Those values are MC is 26 point. Please tell me louder.
26.90
Divided by
82.82.
82. So that gives us 0.32. This is the coefficient of static friction. Okay. Now we will go on to find the kinetic friction. Right. So kinetic friction, you see, as the body moves, as I told you yesterday, once it starts moving, the friction will reduce. The friction will reduce. So now you see, this one is also accelerating. This is also accelerating. Okay. So as far as the acceleration of this is concerned, it is going to be mc into g minus t. What is mc g minus t? The net force acting on this. Right? The net force acting on this is this, and this divided by mc will give you the acceleration of this. Right? As far as this is concerned, what is the what are the forces acting on this? See, on this now, or if you take this body, one force is tension, that is acting, and the other force is friction. It is kinetic friction. That is acting. The kinetic friction is acting this side, the tension is acting this side. Okay? So now here you see mcg minus t and this minus t. Okay? So this is the net force acting. So this net force divided by the mass of the trolley gives you the acceleration of this, and this divided by this divided by mc will, this net force divided by mc will also give you acceleration, and both the accelerations are same because both of them are connected together like this. Okay, understanding? If you have any questions, you can ask. Okay, right. Okay, so what I am going to do now is already acceleration we have found out. Okay, the coefficient of kinetic friction is what we have to know. So this friction that you see here is mu k into mt into g. This is the friction. Okay, so I hope you understood these equations. You have any questions? Now you see, I will take this slightly higher. So this was our container and this was our volume. Okay. Now these two are connected by a spring. You can consider them as a system. So on this system now, the tension becomes an internal force. Right? So forget it. Now what are the external forces acting on this? One is, yes, good. So mc into g is one external force and friction is another external force. Okay? Friction is another external force. So what is the net force on the system? It is accelerating. What is the net force? What is the net force? This force minus this force. See, you see, you don't see this board. You see what happened yesterday. That the container was going down and it was pulling the trolley. So that means now there is net force acting. See, this is pulling and frictional force is opposing. But still the net force is more than 0. So therefore the entire system is accelerating. Did you understand?
Yes.
So therefore now what is the net force?
mcg minus u minus t.
Excellent. mcg minus ukmtg is the net force. Okay. So then what is we found out that it is accelerating A. So therefore acceleration will be equal to mcg minus ukmtg divided by whole mass of the system. What is the total mass of the
MC
system?
plus MT.
Yes, very good. MC plus
MT.
This is the total mass. So we have related all of them. So now you see acceleration we just found out. We just found out now in the next board we have found out now. We found out the acceleration here, right? 0.8347. So acceleration is found out by experiment and calculation. MC is your weight, G is you take it as 9.8, and MT you weighed and found out, G is again 9.8, and then MT is known, right? So in this only unknown quantity is this. So find out mu k. Find out mu k. That's it. Okay. So I hope you can do that, right? So we will write the equation in terms of mu k, and we shall see what is the value of mu k. Okay. Okay. See, all this technology is available now. It's a great pleasure for a teacher to teach, especially physics teacher. Okay. So we can do so many things on this. Draw, type. So many other features are there in this. So I am going to now write it in terms of UK, right? So in terms of UK, I am going to write it. UK is equal to CM. A into
MC plus MT.
okay, and so this I brought it here, and MCG is this side. MCG is this side. Okay. So I'll just write it. You see. Now I'll write minus here, plus here, MCG divided by MPG. See what I have done here. See this I multiplied it by this. And mu k MT is there, so I brought mu k MT to the left side. And this one MC MT A I brought it to the right side, so it becomes minus. Okay, only thing is I am writing minus this, you should not get confused. And this mu k is multiplied by MT into G, that MT into G I brought it up. Okay? Now you are going to substitute all these values and you should get the answer. Okay? Okay. So what are all the values that we have got here? So A value how much Mantama? MC value ಎಷ್ಟು ಹೋಗ್ಲಿ container
26.90.
26.90.
Acceleration is equals to 0.8.
Wait, just wait. Into G. G is 9.8. Minus. Acceleration is Mantama?
0.8347.
8347. Okay. Into MC plus MT. How much?
26.90 plus 82.82.
Right. Divided by MT. Again it is
82.82 into 9.8.
So now you have to do this calculation. Okay? And then you will. Okay. I use the calculator and I calculated it. I am getting it as 0.2119. Okay, it is unitless. So you see here, mu s is coefficient of static friction. It is more, and mu k is coefficient of kinetic friction. It is less. That is why the kinetic friction is less than static friction. And it. So I hope you understood friction, right? Friction between the two surfaces. Clear, students? Right. Thank you very much.
You will find links for short videos in the description below to understand this system. You can also write to me for details. sudhirmurthy.feed@gmail.com or WhatsApp 9844118615. Thank you.